discuss about different types of indicator, and also we have discussed an experiment in which the acid it reacts with metals carbonate and metal hydrogen carbonate, or we can also call it as metals bicarbonate. In today's our fourth revision session of chapter 2 acid, base and salt, we are going to discuss about the concept of pH. Also we will discuss that how in our daily life pH is important, and we will also have a look on the concept of strong acid, strong base, weak acid, weak base, concentrated acids and dilute acids, or concentrated base or dilute base. So let's start our journey with the concept of pH. This P, it stands for potence in Greek. It means power. So potence, which stands for P, and H means power of H plus. So by pH scale we can have a power of concentration of H plus or of OH minus. This pH scale was firstly developed by S.P.L. Sorensen, right? In 1909 it was developed by S.P.L. Sorensen. This pH scale is between 0 to 14. Now 0 it means very much acidic, and 14 it means very much alkaline, means basic. As we all know that between that there will be 7. So this 7 it stands for neutral, right? So it's very clear to you that less the value of pH, our solution will be more acidic. More the value of pH, our solution will be more alkaline or basic. Let's try to understand it with one example. Suppose if I have a solution A which have a pH of 5 and the another solution of B having pH of 2. So yes, you are right that our solution B is more acidic than our solution A. How much more acidic it is, we are not going to discuss it right now, right? So this way pH scale is between 0 to 14. 0 means too much acidic, 14 means too much alkaline. Between that 7 which stands for neutral. Okay, as we have understood this concept of pH, so we can also have a formula of pH which is equal to minus logarithm base of 10 concentration of H3O plus. Here as we know that H3O plus, how it is formed? It is formed by reaction of H plus with H2O, because H plus is highly unstable which reacts with water to form H3O plus, which is known as our hydronium ion. So the negative value of logarithm with a base of 10 of concentration of hydronium ion, that is considered as pH. Same way we can also have a power of OH which is known as POH, that's equal to negative value of logarithm at the base of 10 concentration of OH minus. So here this will be also the formula of POH minus. Now one more concept is necessary, that pH plus POH, it will be always equal to 40, right? Different sums we will calculate on the basis of this formula. Now from this concept I can ask you one question, that if for solution A the pH value is 5, so what will the value of POH? Now it's clear that if here it is 5, so 5 will go at right side, so 14 minus 5 you will get the value of POH. here the value of pOH for the given solution, that will be how much? Speak it loudly. Yes, it will be 9. And for this, the value of pOH, how much it will be? If pH is 2, so pOH will be 12. So this is the common concept of pH, right? So how this pH is important in our daily life, how it is connected with us, that all we are going to understand. We will talk about animals and plants, how it is important in terms of sensitivities. Also we will talk about importance of pH in soil. We will also take a look on digestion, how pH is important in digestion. Also, we will have knowledge on how it is responsible in tooth decay and as a self-defense by animals and plants. Right? In this fields, we are going to understand the importance of pH. So let's start from the first one, that is animals and plants. Generally, our body works between a certain range of pH very properly. Our body works between pH of 7 to 7.8, right? Very properly. If there is more variation in this pH, it may be create disturbance to our power rhythms. If the pH of the water, of the rainwater, it decreases than 5.6, if the pH of rainwater is less than 5.6, it is known as acid rain. And we know that due to this acid rain will get into different water bodies, and in this water bodies there will be different organisms. Due to this more acidity in that water bodies, the organisms will get affected and there will be a problem in their survival. So due to this acid rain also, the plants and animals, they are sensitive, they work in a certain range of pH. If suddenly there is a drafting change in pH, so the survival of that animals and plants, it is difficult. Due to acid rain, many times the aquatic organisms, aquatic plants, aquatic living beings, they get disturbed. So in this way, animals and plants have a certain range of the sensitivity, a certain range of pH is desirable for them. So it must be always maintained. Now let's talk about importance of pH in soil. Generally we know that plants will have a well-developed growth. They will develop very well in a certain range of pH. Right? Sometimes the soil becomes more acidic or more basic, that is undesirable for us. To maintain a proper amount of pH in soil is very necessary. For that, sometimes we are using calcium carbonate and gypsum to maintain the certain pH level of soils, and due to that there will be a growth of plants. Right? So in soil, a proper pH range must be maintained. For that, we are using different substances like calcium carbonate and gypsum. If the acidity increases, if the pH get down, acidity get increased, so at that time we have to add the basic substances and to make it neutral. And if the basicity is increased of the soil, so we have to add some acidic substance from outside. So that was the importance of pH in soil. After that, we discussed about digestion. In digestion also, how it is important. We know that in our stomach there is secretion of HCl, and if that secretion of HCl is increased, so it will feel irritation in our stomach, which we call it as acidity, right? So if there is more amount of HCl in stomach, which will create acidity. So what we have to do now, as due to this acidity there will be irritation in the stomach, so we have to add some basic substance, and that basic substance will react with the more amount of HCl in our body and will nullify that effect, and it will become neutral. So for that we are using antacids. Now what is antacids? They are different type of base which nullify the effect of more acidic and maintain a certain pH in our body. So this way, in digestion also, a proper range of pH is very necessary. If there is acidity, so we are using antacids generally, which are base and which nullify the effect of acid which is secreted during the process of digestion. MgOH twice, generally that's known as milk of magnesia, right? MgOH twice, which is known as milk of magnesia. Other substances, if we talk about baking soda, baking powder, right, that also we are using as an antacid, right? So that is our sodium bicarbonate. So different type of antacids we are using to nullify the more acidity of the stomach, right, in the process of digestion. So this way, importance of pH in soil and importance of pH in digestion we have. Now let's discuss about importance of pH in tooth decay. Generally, if the pH of a mouth it comes to less than 5.5, so this type of problems is done. If we talk about it in detail, so we will use to know that calcium hydroxyapatite, calcium hydroxyapatite, crystalline or crystal form of calcium phosphate, right, which is enable on our teeth. Generally we know that this enable of calcium hydroxyapatite, which is a calcium phosphate crystal form, it will not dissolve in water. So it is not dissolve in water. But when the pH of our mouth it decreases from 5.5, so it will start getting corroded. Now how it get less than 5.5? We know that the food which we eat, right, that will be between our teeth, and that food which is plucked between the teeth, it will start degradation, and due to this degradation it will start creating acid which decreases value of pH, and it will become less than 5.5, which will affect to our crystal form of calcium phosphate, which is known as calcium hydroxyapatite, right, which is insoluble in water. So the food particles which is there between your teeth, it will get degraded and it will increase the acidity, which decrease the level of pH in our mouth less than 5.5, which is very harmful for us. For that, what we can do, we can use the toothpaste which is basic. So what will happen? It will manage the pH above 5.5. So this layer or the crystal form of calcium phosphate, it will not get affected, and our teeth, it will not get. Okay. And the last importance of pH, that will be in sting of honeybee or sting of nettle leaves. Generally we know that when honeybee it bites, in the sting of honeybee, it will enter the acids in our body, and due to that it will feel the irritation. So at that time what we have to do, we have to apply the basic substances like baking soda, so which will nullify the acidic effect of that sting of honeybee. If we talk about nettle leaf sting, so in that also we know that there is presence of methanoic acid, and due to this presence of methanoic acid it will be there will be irritation, and to avoid that irritation we have to nullify the acidity. For that we have to apply the basic substances on the sting. So this way, in self-defense by animal and by plant, the importance of pH is connected. As we have studied in different points that how pH is important to us, we also know that some of the medicines in that the maintenance of pH is very necessary. That's why in some cases doctors say you that to take this medicine with milk and to take this medicine with water. Only some specific medicines are taken with milk to maintain the pH level of our body. Even some of the medicines, it will not work if the pH level of our body is not maintained. So according to that, importance of pH is very necessary topic to understand. It's also very necessary to gain the knowledge, right? So this way we have completed our topic, that is importance of pH. There are many different areas in which pH is very necessary, but according to our syllabus we have just taken only this point, that how it is related with animals and plants, how it is related with soil, how it is important in digestion, how it is important in tooth decay, and how it's useful or how it is connected in sting of honeybee and in nettle leaves. So in today's session we have understood about pH, right, and importance of pH. Now let's discuss about some of the important definition, that is strong acid and strong base. On the other hand, weak acids and weak base. It's very easy. If we take any of acid and if we add water into it, after adding water into it, means by doing dilution of it, if it is completely ionized, so here if the acid is completely ionized, so that is called strong acid. Similar for strong base means if in a base when we add water and the ionization of the base is done completely, so the base which is completely ionized, that will be a strong base. Here we can take the example HCl, H2SO4. As a strong base we can take NaOH and KOH. Now what do we mean by weak acid? Weak acid means the acid which is not completely ionized, means which is partially ionized. They are known as weak acid, like CH3, COOH. And weak base means the base which is not completely ionized, that is called weak base, like NH4OH. Now it's very easy to understand. When we will take 1 molar of this acids and if it give us 1 molar of H plus, so that is completely ionization, so that are strong acids. Here also if I take 1 molar of this bases and by ionization if they give us 1 molar of OH minus concentration, so they are completely ionized, so that will be our strong base. But here, if I take 1 molar of solution and it will give us less than 1 molar H plus. So that means it is not completely ionized, so that is weak acid. And same here, if I take 1 molar of weak base and it will give us less than 1 molar of concentration of OH minus, so that will be our weak base. So see, here it's very necessary to understand that the concept of strong and weak is related to their ionization. Well, to another words, concentration and dilute, it is dependent on portion of water. If in any acid water is in less portion, so it is called concentrated, and if the water is in more portion, so that is called dilute. So it's very necessary to understand that concentrated and dilute, it is different than strong and weak. Okay, strong and weak, it is dependent on ionization, while concentrated and dilute, it is dependent on amount of water. So if I talk that I have taken HCl and more amount of water is added, so more water is there, so that will be dilute, and HCl is strong, so our acid, that will be strong and dilute acid, right? So this way both of the concepts of strong, weak and concentrated and dilute we have completed. So in today's section we have discussed about what is pH scale, importance of pH scale, and definition of strong acid, strong base, weak acid, weak base, and concept of concentrated and dilute. Thank you.